Presentation.
Hello. Good morning, everyone. Am I audible?
Yes, sir. Audible, sir.
Yes, sir. It's audible.
Okay.
Yes, sir.
Thank you.
Yes, sir.
Thank you very
Audible,
much.
sir.
Distinguished resource persons and participant colleagues, good morning to all of you and a warm greetings on behalf of Bangalore Institute of Technology and Engineering, Moodabidri, Karnataka. Here is Dr. Rajshekhar CR, Professor of the Department of Mechanical Engineering, MITE, and the coordinator of the FDP. Welcome you all to this 5-day online workshop on emerging trends in sustainable technologies. The objective of this faculty development program is to provide an exposure to faculty members, practicing engineers, and postgraduate students to the concepts of recent advances in renewable energy technologies. The FDP emphasizes on societal impacts of ever-increasing energy demand, need to switch to greener alternatives in energy domain, an overview of sustainable technologies, product prototypes in renewable energy systems, thermal management of photovoltaic modules, fault identification in solar farms, sustainable energy integration in smart cities, design thinking of conventional and hybrid electric power trains, sustainability in heating, ventilating, air conditioning and refrigeration, and wind energy conversions. India is one of the countries with large production of energy from renewable sources. As of 31st March 2020, about 35.86% of India's installed electricity generation capacity is from renewable sources, generating about 21.22% of total utility electricity in the country. In the Paris Agreement, India has committed to an intended nationally determined contributions target of achieving 40% of its total electricity generation from non-fossil fuel sources by 2030. The country is aiming for even more ambitious target of 57% of total electricity capacity from renewable sources by 2027. According to 2027 blueprint, India aims to have 275 gigawatt power from renewable energy, 72 gigawatt of hydroelectricity, 15 gigawatt power of nuclear energy, and nearly 100 gigawatt power from other zero emission sources. Coming to this faculty development program, we have totally 15 sessions, including one session on human values, on health and happiness. We have wonderful audience here as registered candidates are from various streams of engineering. I request the candidates to attend all the sessions and maintain 80% of attendance. On the last day of the program, one MCQ will be conducted. The questions will be based on all 15 sessions. After the test, the candidates are requested to give the feedback which is available on candidates portal. To receive the FDP certificate from AICTE, I take this platform to thank ATAL-FDP for having given an opportunity to organize an FDP and have good network with you all. I would like to express our deep and heartfelt gratitude to Dr. Ravindra Kumar Soni, Director, and Dr. Girdhari Lal Garg, Assistant Director of ATAL, for good support and timely suggestions to organize this program. I personally thank our management, in particular our chairman, Mr. Rajesh Chevta, and our principal, Dr. GL Ishwar Prasad, for their great support in organizing this program. Once again, I welcome you all to this FDP. Have wonderful days ahead. Thank you all. Now, I request our Professor Dr. Lokesh to welcome the resource person of the opening session and introduce to audience. Thank you.
Good morning. Before I introduce our today's resource person, let me highlight the today's sessions for the benefit of the audience. Today we have the morning session from 9:30 to 11. It is from exactly from 9:30 to 10:30 and another 15 minutes of question and answers. Then the opening session, centralized opening session from AICT Center will start. Afternoon session is from 2:30 to 4. Since we have the complete humanity is under stress, we have one great personality from ISKCON, Sanadana Das, who will be relieving from all the stresses what we are going through at this pandemic stage. It is from 2:30 to 4. Then we have the session from 7 to 8. It is on product prototype in renewable energy systems and sustainability. Having introduced the today's session, let me take the pleasure of introducing our resource person, Mr. Deva P. Seetharam. At present, he is working on data-driven energy systems for more than 11 years. Mr. Deva P. Seetharam is basically completed his engineering from Bharatiya University, and he completed a master's degree from MITE Media Laboratory. Also, he worked in this from January 2015. He founded Data-Driven, a company that develops machine learning and IoT technologies for solar and storage systems. Company solutions help solar plant operations to maximize the energy generated by their installation and distribution companies to optimize the incorporated distribution energy resources. The company is profitable, and when he was the CEO, its annual grew by at least 225% year on year from 2015 to 2019. Glen was received many honors and awards, and in that some of them to list is NASSCOM's AI for Good Award, Free Electrons, one from the 12 most innovative energy startups in the world, Amazon's Best AI Company Award, Microsoft Research Best Edge Analytics Project Award. Many more awards will go on for this company, but just for the benefit of the audience, and I'm streamlining it to some of the awards at this stage. Prior to this, our resource person has also worked for worked from December 2018. He worked for Smart Energy Research Initiative for IBM Research India, and he led it until June 2014. His group has developed various computing solutions like supercomputing, edge analytics, IoT, machine learning, etc. for enabling smart grids and distributed energy systems. His research group worked on 10 utility companies in 4 different continents. The group research led to 23 granted US patents and 50 research papers. The group work has been recognized with an MITE TR35, an Indian National Academy for Young Engineers Award, three Best Paper Awards from ACM and IEEE conferences, and 10 IBM Corporate Awards. Technologies developed by this group are the part of Utopus Insight innovative HD radio technologies and applications, radio sharp was acquired by Tuneling Inc., a company backed with Sequentious Ventures. He has been granted 20 US patents and has also published more than 50 papers. His works has been cited by more than 1,430 times with a H index of 21. He has been conferred with IoT Thought Leadership Award by IET. His bio profile will goes on, and we are lucky to have such a resourceful person on this opening session. I thank Mr. Deva Seetharaman for accepting our invitation and for sparing his valuable time. Dear sir, I take this opportunity once again to thank you, and the floor is open to you. Open to you, sir. May I welcome Deva Seetharaman to take over the floor. Deva sir.
Yeah, thank you, sir, for your very kind introduction.
I have an announcement. May I request all the participants to mute their mic and also the camera for the benefit of not disturbance for any of the participants who are participating. So please follow these guidelines, which will help all of us. Open to you, sir.
Thank you, sir. Thank you very much for your very kind introduction. Can you hear me?
Sir, we can hear you. You'll have to put it for presentation. I removed my presentation.
Okay.
You can click on present now.
Yeah, it is not showing my presentation screen. I don't know why.
Sir, can you see that present now screen? If you move your mouse bottom
yes, sir,
of the
I
screen.
can. Yes, sir, I can see. I've used it before, but right now, it is not allowing me to, show the presentation, particular presentation slide.
Yeah.
One second.
Maybe I can help you. What you do is move your mouse down so that button will pop up, which shows about turn on caption, present now, and the 3 buttons.
Yes, sir.
Yeah, click on that present now.
Yeah.
Okay.
And then it shows 3 options, sir. Your entire screen, a window, and a Chrome tab.
Put on entire screen.
Yeah. So when I click on the entire.
Yeah, put on entire screen.
Uh-huh.
Select that. Click on the entire screen and select that screen. Click on share. Yes, you are presenting, sir.
Are you seeing my slides?
Yeah, now you have to pin to your presentation, or shall I will pin that.
Are you able to see my screen?
Yeah, I can see you. I can see your screen. Yes, sir, it's ready.
Okay, so you are seeing that an overview of sustainable energy.
It is fine. It is fine. It's fine. You can go ahead, sir.
Okay, great, wonderful. So, good morning, everyone. Sir, thank you for your very kind introduction, and thanks to MITE for inviting me to come and give this presentation to such an august audience. First of all, happy Teachers Day, belated happy Teachers Day. Both my parents were school teachers. I know how noble the profession is, and you all get to shape young minds and the future of this country and future of this world. Even now, I look back and thank some of my teachers who shaped my thinking and shaped my outlook towards life and what I should do and what I should prioritize. So thank you all. You're doing such a great job and a great profession. A couple of things. First of all, let me acknowledge, right? I've been blessed to work with some great colleagues, both at the IBM Research Labs, in the company that I co-founded, Glen, and collaborators and advisors over the years, and my teachers and professors, and my family, of course. They all shaped my thinking and helped me understand this subject and gave me the pointers, right? So, so one thing I wanted to say about my talk is that two things, right? As a professor mentioned, the audience come from wide variety of disciplines. So I have kept it very generic. I have not gone too deep into, say, machine learning or IoT or whatever, because I was told that there are people from mechanical engineering, civil engineering, they may not be familiar with. And second thing is, more importantly, I do not know much about these fields anyways. So I'm giving a general introduction or an overview of this whole area. And the second thing is, please feel free to ask me questions, right? I mean, I don't want it to be a monologue. And, I would like to engage in a discussion with you. I don't know how the question format works. I'm sure, Professor Rajshekhar, who is coordinating this, will help us through the process. But, that's what we can do. So, the first section is the introduction. So when you look at it, right, and UN says the climate change is the most important problem, right? Why? The sustainability, we all talk about sustainability, sustainable energy systems, sustainable technologies, and so on and so forth. What does sustainability mean? Sustainability means it is the coexistence of the biosphere. The biosphere means atmosphere, hydrosphere, and the lithosphere. The lithosphere is the land, the hydrosphere is the water, and the atmosphere is the air. So there are living beings in this entire area. So 20 kilometers above the ground and 500 meters below the sea level, you see sentient beings, or you see living things, whether plants, animals, microbes, and mammals, and so on and so forth, right? How do we coexist? How do humans coexist with the other species? And how can we still continue our economic activities without destroying the ecosphere? That's what sustainability means. So how do we do this, right? So like, look at the COVID. We thought we can continue to do our economic activities, but like one virus has completely locked us down. We are all sitting in different parts of the country and listening to this talk, and I'm presenting from here. So climate change has a similar, very powerful problem that we have to pay attention to. Right. So as I mentioned, UN defines climate change as the defining issue of our time, and we are at the defining moment, right? So this is a very important problem, and then we all need to understand the depth and breadth and understand what is the best thing that we can do about it, right? So what is climate change, right? We all talk about climate change, and the climate change is primarily caused by the greenhouse effect. So what happens is the sunlight hits the earth, and usually until about 50 years ago, most of the light would get reflected back to the atmosphere, and it would just go away. Earth was not warming. But what has happened is, because of the greenhouse gases like carbon dioxide, methane, and nitrous oxide, and so on and so forth, they are like, have created a like a layer above the atmosphere, which is absorbing all the sunlight and reflecting back. I hope you are able to see the animation. The sun is absorbed and radiated as heat. So that is an issue that is really warming this planet and affecting the living beings, affecting the temperature and the balance, right? So when you look at the this plot, can anyone acknowledge whether you are able to see the plot? The temperature was a solar activity. Hello? Yes, sir. Hello, hello.
Yes, sir, it's audible.
And can you see the
Yes,
slide
sir.
and the
Audible,
plot?
sir.
Temperature versus
Yes,
solar
sir,
activity?
it's audible.
Yeah,
Yes,
we
sir.
can see, sir.
Yes,
We
sir.
can.
Okay, okay,
Yes,
great.
sir. Yes, sir. We can see.
Okay, thank you, sir. And so, what happened is, like, this plot is from NASA. What they are showing is, the red line is the Earth's surface temperature. As you can see, from 1880 to 2020, the Earth's surface temperature has been going up like this, and the solar irradiance, the amount of solar irradiance on the planet has been pretty much constant. So the thick yellow line is 11-year average, whereas the lighter yellow line is the annual averages, right? So this is what you are seeing. As you can see, even though the irradiation has remained constant or has even gone down, as I'm pointing using my mouse cursor, the surface temperature has gone up, right? That is because of the greenhouse gas effect. So what is the human involvement? Is it natural or is it the human involvement? Most of the signs indicate that it is because of the human involvement, and many of the scientists, or I should say, most of the scientists say that it is, the humans are primarily responsible for what is happening to this. So here, in this plot, as you can see, the global surface temperature, the red line is only the human drivers. Again, the NASA did the work. The total observed temperature has gone up by 2 degrees Fahrenheit, as you can see on this plot. And the human activity is the red line that is increasing, right? I mean, that is because of this, 1.5 degree Fahrenheit has gone up. And because of the natural things, it's about 0 to 0.5 degrees kind of stuff, right? So together it has increased, the overall global surface temperature by 2 degrees. So how are we doing this? We are doing this in many possible ways. One of the things on the right side is, as you can see, the rainforest in Amazon. That is home to about 10% of all the species on this planet. We are doing deforestation of those rainforests. I mean, we are killing so many of the species, and as you can see, it is called a fishbone pattern. Until about 1972, this jungle was dense and it was very hard to get into. And then they started building a highway, and people started encroaching, and started doing plantation, and that has completely gone down. And as you can see from this red line on this plot, can you see my cursor? So which shows that red line declining, right? That shows from 1972, what is the percentage of the rainforest which is still remaining right now, right? That is what this plot is showing here. So that is one activity. And the second thing, that the one below I'm showing, is the Aral Sea that is between Kazakhstan and Uzbekistan. The big water body you see is in 1968. And then what you see right now, that the thin line is all which is left now, because the most of the water was directed towards irrigation in the former USSR and Russia, and the lake has become so much. So you can imagine, right? We are completely messing up with the planet, right? We are changing the, reducing the amount of forest. We are reducing the size of the water bodies. We are emitting all kind of greenhouse gases, etc. So what are the consequences of the climate change? What are the effects of the climate change, right? So it is anywhere between wild forest fires. I mean, there was recently for huge forest fires in Australia, in San Francisco. There are extended droughts and tsunamis. It is really, really getting nasty out there. I mean, think about it, right? I mean, they expect by 2050, this situation is going to get really worse. And some of your students who are in their, below 20s or 20s, by 2050, they will be in their middle age, and they are going to face the whole wrath of this climate change, right? So Richard Smalley is a Nobel Prize winning chemist. So he classified top 10 problems facing humanity, right? I'm just going to run through because of the lack of time, right? So the look at the slope of the world population. It is pretty much infinite. From 6 billion in 1999 to we have reached 7 billion in 2019, and we were 7 billion in 2011. We have added about 0.7 billion in the last 8 years, right? So that is how fast the world population is growing. And there are about 50 autocratic countries in this world. I mean, still democracy is not there, right? And there are autocratic regimes suppressing and oppressing the people in those countries. There are about 675 million people who, even though they go to school, they cannot do basic addition and basic literacy, right? Even the primary education is deprived for many people around the world. Primary education is one of the issue, right? Lack of education opportunities. And diseases, I mean, I don't even need to talk about it, right? I mean, nowadays people are wearing masks to Zoom meetings. That's how scary it has become, the pandemics that is affecting this world. And the terrorism, right? I mean, this is the 9/11 attack in the US that happened. And also there is domestic terrorism. You must have heard about, the Black Lives Matter movements and, what is happening in the US, and all the shootings happen in different parts of the world. There is domestic terrorism and the international terrorism. Next is the poverty, right? I mean, this is a picture that was taken in Sudan in 1993. The guy who took the picture, committed suicide. As you can see, the kid is the boy here doesn't have enough food, and the vulture is waiting for that kid to die, and so it can eat it. The guy who took this picture won a Pulitzer Prize award, but he couldn't take it, and he committed suicide within a few months after taking this picture, right? So there is so much of poverty, and in fact, a significant percentage of the people, about 10% of the people, live below, $1.9, which is about 140 rupees per day. About 700 million people are living with that kind of income, right? You can see how tight their lives would be. In fact, as you know, I mean, as educators, right? I mean, because of this poverty, many kids are not even able to attend the online schools because they don't have computers, internet connections, so they are not able to attend online classes, and they are losing out. So then there's the pollution, right? I mean, there is a plastic pollution, air pollution, etc. As per the recent World Health Organization estimate, 10 of the 11 most populated cities in the world are in India, unfortunately, right? 10 of the 11 most populated cities, especially of the, the medium, the 2.5 micrometer particulate matter pollution, 10 of the 11 cities are in India. And the food shortage, right? Again, there is, because of the food shortage, there are a lot of people having difficulty getting basic food, and there is, on the one side, there is too much of obesity, and 1.59 billion adults are suffering from overweight, and 462 million people are underweight, and among about 52 million under 5 children are not getting proper food even to grow and even to sustain themselves, right? And next is the water shortage, right? There is only 0.014%, 0.014% of the water on the earth. Only that much is a fresh water and can be easily accessible. Of the remaining 97% is saline water, and 3% is difficult to access, right? And 1.1 billion people lack access to fresh water. That is the sadness of the situation. In spite of all the magnitude of these problems, what he says is that access to clean and cheap energy is the single most important problem facing humanity. So there is a great paper he has written. I put it in the references. The reason why he says is that if we are able to solve the energy problem, if we are able to provide clean and cheap energy to the entire world, all the other problems can be solved. For instance, the water shortage, right? I said 97% of the water is seawater. And if there is clean and cheap energy, we can desalinate, right? For instance, in Singapore, they desalinate the seawater to get the fresh water. But it takes about 2.7 units, 2.7 kilowatt hour of energy for desalinating 1 cubic meter of water, right? But if the energy is cheap and clean, you can desalinate the whole sea and you can get the seawater, or you can educate the whole world, right? I mean, once energy is available, anything else can be done, right? Why energy is the crucial issue, right? So the reason is right now, our consumption is about 20 terawatts, right? By 2050, it is expected to increase to about 50 to 60 terawatts per day. 20 terawatts per day now, it is going to increase by 2.5 times in 2050. And also more than 70% of all the greenhouse gas emissions happen because of energy generation and energy consumption, whether it is a industry, whether it is a residences, transportation, everything. So energy is the crucial issue. If we are able to solve it, we can, we can address all the other problems, right? This is very, very important. So I wanted to talk to you about two different approaches. One is on, microgrids, right? Professor Rajshekhar, should I stop here and ask if there are any questions, or should I continue the presentation and take the questions later?
Sir, Dr. Deva, sir.
Yes, sir.
I have requested the participant to post their questions on the chat, and the question and answer session is from 10:35 to 10:45. If you can wind up by 10:30.
Okay, sir. In another 35 minutes, I will finish the presentation. Right? So a microgrid, right, is a localized grouping of generation and the generation, storage, and the loads. So basically, the generation and consumption happens at the same place. Instead of like generating in a large power station somewhere and transporting the electricity to where the consumption happens, microgrids make it completely decentralized and local. And there are different types of microgrids, but I will not discuss that right now. And also one other thing that I wanted to mention is that in this presentation, I'm going to focus primarily on electricity as an energy form, because most of the things are getting electrified, and it is one of the cleanest forms of energy. So I'm going to focus only on electricity. As you know, there have been many historic microgrids, right? But in fact, the time seems to going back to the past. We started out with the local energy generation and local consumption, and again, this is going to be the trend in the future. So there are two types of, this is a comparison between the conventional macrogrids, the centralized power grids, and the microgrids. The key points that I want to, highlight are the few things, right? So the grid installation costs, like there are about 200 million people in India don't have access to electricity. 200 million people, right? 1/6 of India does not have access to electric grid. But if you want to extend the grid, if you want to put more poles, transformers, wires, it costs about $8,000 to $10,000. It's about 7 lakhs, 6 to 7 lakhs per kilometer of extension. So it gets very, very expensive. And also we need to increase the generation capacity. Another disadvantage of extending the grid is that it can increase the network losses, because energy travels for hundreds of kilometers if it is a centralized power station. So a lot of energy gets wasted in transmission and distribution. In India, about 10% to 20% of the energy gets lost in this transportation. But one of the good advantages of the centralized grid is they can do multiplexing. If there is generation, if some group of customers are not using, some other group of customers can use it, right? But in a microgrid, if there is generation and if you don't use it, that energy gets wasted. And outage impact can be very high. If there is any power cut, the whole area, the whole city gets affected. In fact, while I'm presenting, in the back of my mind, I'm worried that if there is a power cut in my apartment, I'm going to lose a connection and I'm going to lose this presentation. Right? And the complexity for consumer is low in the centralized grid, because all they have to do is flip the switch and use. Whereas in a microgrid, they need to take charge and manage things. And opportunity for organic growth is less in central grids, because they have to plan and do it. Whereas in the microgrids, you can add more and more and, build the capacity, right? I will stop here and go to the next point. So when I was in IBM research, we created something called UGrid, a very sophisticated operating and a sophisticated and efficient operating system for managing these microgrids, UGrid. So we deployed this UGrid in the middle of a rainforest. I will just go through and explain that to you. So KBFSC is a Kuala Belelong Field Study Center. It's a rainforest research center in Brunei. So to get to this place, we have to take a flight to Bandar Seri Begawan, which is the capital of Brunei, and then we have to take a ferry to reach an island called Temburong, and then we have to take a road vehicle to reach the other end of the island, and from there we have to take this canoe to reach this research facility, right? So as you can see, this is the canoe which is on the right, where the diesel cans are transported, etc. So when I went to this place, I mean, it's a pristine rainforest, right? There is no electricity and there is no human pollution, and they want to preserve this area very pristine, right, with all the oil money, ironically. But the thing is, like, what I noticed was, which was weird, was that it's supposed to be a pristine rainforest, and the only source of electricity was diesel generators. I mean, there are three diesel generators. There is no grid connectivity, and there are 5 buildings, and maximum of 70 people can be accommodated in this place. On an average, about 1,000 people stay per year, and researchers come from different top universities like Harvard and Oxford, come and do the research in this pristine rainforest. They are still discovering new plants and animals in this rainforest. And 1 out of those 3 30-kilowatt diesel generators run, and about 30 liters of diesel are used per day. But because of the difficulty of transporting diesel, the electricity is available only for 10 hours per day, right? Not throughout the day. So it gets difficult for researchers to do their research, and whether it is writing notes or doing anything, it becomes very difficult. So we thought, like, what is that we can do? How can we increase the power availability? Instead of like only 9.5 hours, can we increase it to say 23 hours or even 24 hours? What can we do? But the key constraint is that we cannot increase the fuel consumption. We have to decrease the fuel consumption also. So that was the objective of our exercise, right? So we said we are going to do optimization both on the supply side and on the consumption side. So I'm sure there are mechanical engineering professors here. One thing that you might immediately know is that the diesel generators have nonlinear efficiency curves. So when the when a DG is loaded about 80% of its capacity, it gives you 3 units of electricity per liter of diesel. Whereas if it is the loading is only 30 to 40%, it gives you only 1.7 units per liter of diesel, right? So what we noticed is that the DGs are sized for the maximum occupancy, and they are loaded for most of the times around 30% and 40%, as you can see on the right side of the plot, right? The right side plot. So we thought, like, how can we take advantage of it? So that means the DG has the capacity, but it is loaded only to 30% and 40%. Can we use the remaining 50% and get more efficiency out of it, right? Sorry. So as you can see that red dotted lines, for some reason I'm not able to see my cursor, but yeah, so this is what it is, right? And as you can see, the red line where the efficiency is about low, where it is 10 to 15 kilowatt. If you see the x-axis, the efficiency is lower, and we are moving it to about 20 to 25 kilowatt load region, right? That is the it's a Cummins diesel generator, and as some of you might be already aware, there are new modern diesel generators which don't have this nonlinear efficiency problem. They have linear efficiency for across all the loads. So we said, okay, how can we do it? How can we do this optimization? So we classified the loads into 2 categories. which are the primary loads, like your lights, fans, and wall sockets. So they can use their laptops. They can sit in the rooms, etc. So all the time they are called the primary loads, and the secondary loads are powered only when the diesel generator is running. You might know Brunei is one of the richest countries, and they, even though it's a remote research facility, they have washing machines, dishwashers, and geysers, and all that kind of stuff, right? So we said, like, the secondary loads, which are these heavy loads, will run only when the DG is running, and the primary loads would be running all the time. So how do we do that? When the DG is off, we said we are going to bring the battery, and we are going to charge the batteries when the DG is running, right? So as you can see in the original scenario, I wish I could show you on the screen what the cursor is. As you can see, right, the top plot, which says the original scenario, as you can see, the electricity is available only for some hours of the day, from 6 a.m. to about 11 a.m. and then in the evening about 3:30 to 9:30 in that region, right? Whereas in the optimized scenario, as you can see, the primary appliances are running throughout the day, and then the DG is running, which is showed by that maroon color blocks. They are running for only the previous allocation time, and if possible for less number of hours, and the secondary appliances are running only through that time. So as you can see on the right side plot, where there is a red line and the blue line, the business as usual is the red line, whereas when our scheme is running, we are able to bring about 52% saving. And when the kilowatt hour per day consumption is only about 20-25, and on the peak days also, we were able to get 34% saving. In other words, at least 30% of savings, right? Both in terms of the fuel cost and also, as I said, the electricity is available for longer periods of time. So we also said, how can we do the demand side optimization? One is only the supply side optimization. Can we also do the demand side optimization? So the idea is that, if we are able to ask the customers to schedule all their loads instead of running the geysers whenever they want, and running the washing machine and dishwashers whenever they want, if they can say, okay, I want to do it at this time, I want to do it at this time, it's almost like the unit commitment in the electric grids. I'm sure the power systems professors will understand. Here, basically, the consumers are saying, we want to use it at certain periods of time. So we can request all the users to come together, which is optimal for everyone, minimize the amount of time they have to shift their things, shift their schedule, and run the loads, right? So that's what we did on the demand side. So this was a consumption visualization, which shows, we can tell, inform the researchers who are staying in the facility how the consumption is going to happen and how they can schedule, right? This is a tool they used for the collaborative scheduling. So they can say, I want to, take a shower using the geyser from this time to this time, and I want to wash my clothes. So based on all the researchers' input who are staying there, the researchers who are staying there, we were able to do a collaborative scheduling. What is the optimal time to schedule all the appliances and run the DG so that everyone's need is met and the DG is also minimally utilized, right? So this worked out beautifully, and even now this is running. We built this in about 2014, and this is running. And one of the things that I forgot to mention was about the batteries, right? Now, we have set up about 74 kilowatt hour of lead acid batteries that are used for getting charged when the DG is underutilized, and they get discharged when the DG is not available to power the lights and the fans and the electric loads, right? So next is the distributed generation, right? The first I talked about the microgrids. Now I'm going to talk about the distributed generation, right? So also, as Professor mentioned, right, solar is becoming an important part of the generation portfolio in India and in different parts of the world, right? What are the attractive properties of solar, right? One is is extremely quiet and local, right? And unlike, say, wind turbine or other forms of renewable energy sources, you can set it up anywhere. I mean, this is a hut in a remote part of Africa, and they can put a solar panel and get electricity. Second, it's extremely scalable. As you know, you can have a very small solar panel, 10 watt, 20 watt, or you can have 2 gigawatt. Now people are actually building floating solar plants on the seas and oceans. Like, for instance, countries like Portugal and China are taking this approach. They are able to build the floating solar panels. And also, the solar prices are falling, and it is reaching something called the grid parity. The grid parity means, the unit of electricity you buy from solar is it's equal to or cheaper than the price you get from the grid. The grid parity has been achieved in many countries. As you can see, the greener a particular country in this plot is, it's cheaper, right? I mean, in fact, as you can see, it has already reached in the US, India, China, and so on and so forth, right? But managing solar installations is difficult, right? One is the harsh conditions. So what I mean by harsh conditions is the large-scale solar plants are in the remote parts. The reason is 1 megawatt of solar takes about 5 acres of land. As you know, in the densely populated countries, the land prices are very high. So they are set up in remote areas, and then there are site engineers who have to sit and watch these things. So there are large solar plants, say 50 megawatt. It is, it's spanning 250 acres of land. And these engineers have to go and walk around and, or even take a motorcycle and go around and fix it. I've been to many of these remote solar plants, and I know it's very, very harsh. I mean, many of these guys are young engineers. They had the dreams that they are going to sit in an AC office and they are going to be doing cool jobs in the middle of a city, but they are sitting in some remote part and managing these solar plants. And there are a lot of equipment failures, right? Because, like, say 1 megawatt of solar, if you assume that it is a 250 watt panel, there are about 4,000 of them. Then there are array junction boxes, and there are so many equipment, they all can fail at any time. And it's also extremely vulnerable to environmental challenges. It's the dust and the bird droppings and so on and so forth, right? I've been to plants like, say, for instance, a plant in Rajasthan, because of even though there is enormous amount of sunshine, because of the dust, the solar panels get covered and then their output gets reduced. But but on the other side, on the one side, I said, the prices are coming down, but it also means the economics gets difficult. It's very, very commoditized. So the plot on the left, which shows, the thick red line, it is showing the power purchase agreement price, the price at which the utilities are willing to buy a unit of electricity from the solar plant owners. Now it has come to about 2 rupee 40 paise. It used to be 18 rupees and 12 rupees, and in that range. Now the prices per unit has come down. So that means if I have to invest in setting up the solar plant, and if I'm getting minimal returns, it is not exciting anymore. Then how am I going to first of all, my profit margin is reduced. How am I going to invest more to maintain it and get more output from that? It is becoming very, very difficult, right? And also the other thing that I want to show is the Swanson's law, which says that for every every doubling of the shipment, the price is reduced by about 20%. So based on the current market trends, every 10 years, the prices are going to halve, the prices of the solar panels. So the price per watt or the price per kilowatt, right? So there are major elements of solar O&M. O&M means operations and maintenance, right? So, there is the preventive maintenance and the corrective maintenance and the condition-based maintenance, right? The preventive maintenance can be panel cleaning. As I mentioned, if it collects dust, if the output can get reduced. And there is vegetation management, the large areas, the grass and the weed grows and they start covering the solar panels and the output reduces. The corrective maintenance is, what are the critical reactive repair I have to do, what is the warranty enforcement I have to do, etc. And the third is the condition-based maintenance. How can I continuously monitor and see even before the problem hits, how can I do the condition-based maintenance? So these are the three major elements of the solar O&M, right? So what are the major variables that are influencing the extent and cost of O&M? What is the system size? Obviously, there are two types of solar plants. One, as I talked about, the large-scale solar plants, that run in megawatts and are hundreds of kilowatts. And there are also rooftop plants, right? As the solar panels can be set up on rooftops. And in fact, the Indian government is pushing for 60 gigawatt of solar by 60 gigawatt of rooftop solar by 2022, right? So there is enormous push. So one of the advantages of putting solar on your rooftop, as I explained the difference between the microgrid and the remote grid, is that I can get the electricity directly from my roof, and I don't have to worry about the distribution losses, one-time investment. I can get electricity for next 20, 25 years. But so as I said, like the different factors that influence the maintenance cost are the system size, what are the O&M services, desired level of monitoring, etc. Right? So how to minimize the cost while making sure that my investments are producing maximum amount of energy. So Data Glen, in the company that I co-founded, we created, this is the architecture. As you can see, there are solar panels which are connected together in the series. It's called the strings of solar panel. I hope you are able to see my slide and the text. The strings of solar panel, the panels are connected together in electrical series, and that's called a string. And these strings are connected together in parallel, that's called an array. And they come to a array junction box, and all this DC output comes to an inverter, and that becomes an AC, and that gets pumped into the grid. We developed an IoT-based solution that would collect data from, whether it is a string combiner box, inverters, and weather stations, energy meters, and transport the data to a cloud. This is the IoT side of the solution. It would transport the data to the cloud, where we run various machine learning algorithms to get the insights about the performance of the plants and to improve the performance of the plants, whether it's a rooftop installation or a large-scale plant, right? So this is a portfolio view. The customer, like in India, what happens is there are a large O&M companies, operations and maintenance companies. What they would say is they will take hundreds of plants or even thousands of plants around the world, and they will say, we will provide your operations and maintenance. You are just an investor. We will make sure that your installations are operating at 80% efficiency, right? So this is the portfolio view. They can see all their plants across the country or across the world. So this is one thing. And I'm not going to talk about all the use cases. I will talk about a couple of use cases for the lack of time. So one is the optimizing the panel cleaning schedules, right? So because if I clean too often, then what happens is that one is the water cost and then the labor cost. One of the sad truths about the large-scale solar plants is they are set up in previous farmlands. Sometimes the farmers are not able to get water and they are not able to get the desired yield. They sell the land to the solar plant owners, even though in some places there are laws prohibiting converting agricultural lands into solar plants. But they don't have water. So if you increase the water usage, that's not good, right? So you have to minimize the water usage, and also, but you have to make sure the panels are clean enough to get the maximum amount of energy, right? So what we did is we were able to analyze the expected output and the estimated output. And if the expected output minus estimated output is reducing continuously, that means it is highly likely that the dust is accumulating. There are many reasons why the plant's output could reduce. It can be because of shadow, it can be because of lack of sunshine, inverters are not performing, and so on and so forth. But using the machine learning algorithm, we were able to extract the signature of why the panel output is reducing because of the lack of cleaning. And we were able to advise the O&M companies what is the right time to clean the panel so they can get the maximum amount of output while minimizing the water charges and the labor costs. Because there are not like a robot operated the water cleaning that is not prevalent. So people have to, the manual laborers have to walk around and wash the panels, right? Second is the O&M response times. I will skip it for the lack of time. And the next one is the track shading issues. As I mentioned, because of the vegetation growing, or on the rooftop installations, it could be the neighboring building construction is going on, or a billboard is going on, or anything is happening. How, if the shading happens, how can we monitor the shading and inform the customers? So in one of the plants that we were monitoring, they had set up it was a rooftop installation, 1 megawatt installation on a spinning mill. Somebody had set up a ladder on the roof to walk across the roof, and that ladder, even though it was pushed down, it was collapsed, it was still causing the shadow on the panels that were lying on the roof, and the output was reducing. So again, using the data analytics, we were able to find out that shading is happening, and we were able to alert them. So the shading, the specific signature that happens is the shading will hit the panels on the west side in the morning, and the panels on the east side in the evening, right? Because of the sun's movement, you will see that distinct pattern will occur, and we were able to extract that, right? And many of our customers are using it. And fourth one is, it is important to inform the utilities for the unit commitment, how much of generation is going to happen in a large plant, especially the 10 megawatt plants. The government has mandated in many states that they have to forecast and inform the utility companies how much is going to be generation, and error tolerance is about 15%, the forecast error tolerance. So we developed very accurate forecasting algorithms. The reason it needs to be accurate is the government imposes penalty if there is a deviation of more than 15%, right? And then the use case 5 is DER optimization, right? So for this, we were working with an Australian utility company. In their case, they have like solar plus the storage in the customer's premises. So how do you optimize this thing, right? How much of energy can be put into the storage, when the storage can be discharged, when the energy can be sold into the grid, so that the customer gets maximum battery life or maximum revenue by exporting electricity into the grid. And also, like let's say if there is a peak load on the grid and the utility company has to buy electricity from the real-time markets, which can be very expensive, if they can inform the customer to discharge their own batteries, and if they are able to satisfy the local demand, both the sides win. The customer gets some financial incentive, and the utility gets lower prices than what they can get from the real-time markets, right? So all this solution, right? I mean, one of the key things that I wanted to point out, like, when you are teaching sustainability or, sustainable technologies, as engineers, the policymakers and, people can talk about it. I mean, only engineers, I think, can build the solutions, engineering tools and solutions. The engineers and scientists can build. But like while building these solutions, we need to think about the unintended consequences. So we don't have that perspective, right? I mean, we think how to make it optimal, how to make it less expensive, how to make it reliable. While doing that, we miss the overall picture. I mean, what is that we are trying to solve, which is making the whole system sustainable, right? One of the examples that I wanted to bring about are this, in Europe, many countries, there is increase of solar and wind penetration. But what happens is, instead of large generation, there are many smaller things. So that means increase in the number of switchgear. And when there is increase in switchgear, and one of the problems that happens is, many of the switchgear uses a compound called sulfur hexafluoride, SF6, right? It's extremely damaging to the environment. As the right side plot shows, the red color square shows, 1 kilogram of SF6 is equivalent to 23,500 kilograms of carbon. If 1 kilogram of SF6 gets leaked into the environment, it is equivalent to 23,500 kilograms of carbon dioxide. So we started out saying that, we are going to create clean energy, we are going to reduce the impact on the environment, but we are creating more impact on the environment by doing this, right? So there is a beautiful study from the Cardiff University, and now the European Union governments are saying that how to replace this thing, what are the other compounds, how to limit this, etc. So while we doing the sustainable solutions, it's important to think from all angles, right? Second is the lithium, right? On the one side, we are talking about electric vehicles. Electric vehicles are environmentally clean, but compared to internal combustion engines. But the thing is, what we are forgetting is the electricity. The electricity used to power these electric vehicles or charge the batteries is not clean. Let's say if it is generated using coal or any of this fossil fuel based, the emissions happen in different part. It's just that it is clean in the metro where the electric vehicle is running. So for instance, in Delhi, there are 1.3 million electric autos are running. But if the electricity source is clean, we have not reduced the overall emissions for the entire country. We might have reduced pollution in Delhi, but we have not solved the core problem. And the second thing is the environmental cost of lithium. Lithium is the primary, the energy storage that is used in electric vehicles. The mining this lithium causes enormous damage to the environment. So the left side plot shows the area in Chile, right? The 65% of the water supply in this Chile is used for lithium mining. And the right side shows, from Washington Post, there is a river in Tibet because of the lithium mining. All this toxic substances are getting leaked into the rivers and killing the fish and the sea creatures, right? And also another thing that is used is the cobalt, which is extensively used in lithium batteries, and that is available only in the Democratic Republic of Congo. And that is causing a lot of socio-political situation there. People are digging cobalt, which is a toxic substance, with hands, and one guy calls it artisanal mines. People are not taking safety precautions and digging all this cobalt, and again damaging the environment, right? So I have 4 minutes right now to complete this. So I just want to talk about the discussions, right? One is when you are thinking about the solutions, when you are teaching, teach them not only about the specific solution, but have a holistic perspective of how to make it really sustainable. And second thing is, the sustainable energy, the clean energy, right? One of the problem is very low energy density. So this is a beautiful work by David McKay, who was a physicist in Cambridge. So when the green lines, the thick green lines show the energy density of different technologies. So if the consumption density of a particular area, the x-axis is the population density, that is the people per square kilometer, and the y-axis is the energy consumption per person. If the consumption density is more than the generation density, for instance, in Bahrain, the consumption density is 1,000 watt per square meter. Obviously, no renewable energy technology is going to be sufficient for that. But let's say if your consumption density is 10 watt per square meter, and your your generation density is 20 watt per square meter, which is like the concentrating solar power, 50% of your land will be covered by concentrated solar power thing, right? The concentrated solar power installations. So it may not be possible. By the way, I just want to clarify the two lines above, the UK sun and the desert sun. When he says when it says 110 watt per square meter, it is not the energy that is generated, it is before conversion. So please note that, because otherwise it sounds ridiculous, right? 110 watt per square meter. So the next thing is the grid issues, right? Sometimes when there is so much of intermittency on the generation with solar and everything, the grid gets imbalanced and destabilized. And in places like India, where our distribution network is weak, the distribution companies are not able to absorb the solar generated from the rooftop installations, and sometimes even from the large installations. They ask the solar plant owners or the solar installation owners to curtail the generation. That means cut the output. As you can see the output here, right? The two plots here show, the right side plot shows, this is on a school. On the weekends after 9 a.m., I think until 9 a.m. there's some NCC program or whatever, and completely the generation is curtailed. And the left side, as you can see in the school, the generation is used until the lunchtime, and during the lunchtime, as you can see, a huge dip like a broken tooth, and then again the generation increases during the afternoon classes, right? So there's so much of generation gets wasted like this. So there are many interesting challenges, right? User participation and required at multiple levels. It requires capital expenses, unintended consequences. How is this going to economically, how the clean energy technologies are going to compete with nuclear energy and shale gas, etc., and the economic feasibility, etc. So there are many interesting challenges, but as Richard Smalley said, this is something that has to be addressed. So I think it's a very, very important problem. I have given a bunch of references here, and please contact me if you have any questions also. And that's where I will stop. It's 10:35 as Professor mandated, so I'm done. So 10 minutes for questions.
Thank you, Deva sir.
Thank you, sir. Thank you for the opportunity.
Sir, there are some questions from the participants. There are some questions from the participants. I'll take one by one.
Okay.
One participant, Mr. Ramzia Ashraf, is asking that, is solar panel have pollution and environmental impact?
Okay. So the solar panel manufacturing process might be polluting, right? I mean, the solar panel manufacturing itself may not be clean, but energy generated from solar itself is clean, right? So there could be 2-3 places where there could be damage from the environment. One is in the manufacturing process. Let's say if you are using, storing the energy generated in the batteries, because batteries are electrochemical batteries. Say if it is the lead acid batteries or even the lithium ion batteries, as I explained to you, still have an impact on the environment. But for a solar panel itself, usually the estimated life is about 20 years. So 20 years you are going to get clean energy, right? And also many panel manufacturers give a guarantee that for the first 10 years, the generation efficiency is not going to go below the 90% of the rated generation capacity, and the next 10 years not below 80%. So once a panel is manufactured, you can get 20 years of clean energy. I hope I answered the question. But I'm not able to see.
Thank you, sir. Thank you, sir. I think, I think Mr. Ramzia Ashraf will agree with you. There is one more question from Dr. Natarajan V. He says, point power production using solar plants and using DC appliances may reduce the energy transportation of cost and square R losses. Shall I repeat the question, sir?
Yes, sir, please.
Point power production using solar plants and using DC appliances may reduce the energy transportation of cost.
Correct.
And I square R losses. Is this possible in our country? And even the question is visible on the charts. You can have a look at that if the question is big, sir.
Oh, no, I understand his question. I think it's a great question, right? It is definitely going to be more efficient, right? One is it reduces the conversion loss because you are not converting from DC to AC. And second thing is if it is locally generated, then you are reducing the transportation losses, right? So definitely the DC is very efficient. And there are many DC grid concepts that are coming up actually, right? I mean, there are DC grid standards, and even there is an IEEE DC grid standards which are coming up. And even IIT Madras, there is a project, where they are looking into DC grids. Yes, that is absolutely useful, and that could be the future where many appliances could become DC. In fact, one key thing I forgot to say, there are DC data centers, because when you look at a computer, right, it's a DC equipment. So many places they generate solar, and they provide a DC bus to power these computers instead of taking from solar to AC, and then AC to DC and powering the computers. They are able to provide the DC supply directly. Any other questions?
Hope Dr. Natarajan will agree with your, yes sir. Hope Dr. Natarajan will agree with your solutions what you have provided. Sir, I have some questions. Since you have a vast experience in
Yes,
AI,
sir,
ML and
please,
IoT,
sir.
I have one question from my side, sir. Can I ask you, sir? How can we use AI for saving energy and improving agriculture efficiency using solar energy, sir? I know it is a broad area, but to some extent, whatever is possible within the time limit, we can enlighten us, sir.
So great question, sir. Actually, so what the thing is that, so for instance, right, in the agri, pumping water is an important thing, right? When is the right time to, water the plants or, water the crops. So one thing is there is this, an Australian initiative from CSIRO. They have come up with a soil moisture sensor, and they actually able to measure how much of water is required by the plant and how deep the water has seeped in right now. Using that data, you can use the machine learning to decide when is the next time to water when is the optimal time to water the plant. There is one use of machine learning. And the second thing is, if you have to pump the water, there are many solar water pumps. Government is also encouraging solar water pumps instead of like AC water pumps. So you can not, when I say AC water pump, I mean ones that are powered by the electric grids. So you can run the water pumps, again using the machine learning algorithm, forecast how much of energy is going to be available from solar, and when is the right time to water the plants, and you find an optimal time to water the plants, so that the plants are watered and then your energy consumption is minimized. So this is one example that marries both the sides using IoT and machine learning technologies, sir.
Yeah, thank you, sir. Sir, can you enlighten more, one more in the same way like AI, ML and IoT? Is it possible for improving the fertile land?
I don't understand the question, sir.
Can we use these modern technologies like AI, ML and IoT for improvement of fertility in the land?
To be very honest, I don't know much about agriculture, right? So one thing, and I will put a link on the chat window where I talked about the CSIRO sensors. It's called via.form, via explained. So you can look at the sensors, and that could be interesting. In terms of the fertility itself, I'm not qualified to answer the question. I do not know enough. I don't have enough knowledge. I mean, I can make a wild guess, but I think that will be comical rather than meaningful, actually.
It's okay, sir. Thank you. Thanks a lot. Any more questions? Sir, I didn't see any of the questions on the chat. So I think all participants are not having any more questions. So I take this opportunity from the Department of Mechanical Engineering, MITE. I would like to share our heartfelt thankfulness to you for sharing your time, sharing your knowledge, and most importantly, your experience which you have got throughout the world with us. Thanks a lot for your time and valuable knowledge what you have shared with us, sir.
Okay, thank you, sir. Appreciate it. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. With this, we are winding up the first session. For the benefit of the audience, let me repeat about the sessions for the today. We have the centralized inauguration session of all FDPs, which will be conducted throughout the world. I mean, throughout the country, sorry, from 11 o'clock. And from in the afternoon session, we have two sessions, one from 2:30, another from evening 7 o'clock. Please do join us for both the sessions. The afternoon first session is on stress relaxation, and evening session is on product prototypes in renewable energy systems and sustainability. Thank you, participants. Please join us for the inaugural session from the AICT office. Thank you, one and all.
Thank you, sir. Thank you.
Thank you, sir.